Next, another one more is the sigmatropic shifts or sigmatropic rearrangement reactions. Sigmatropic shift or rearrangement. Sigmatropic shift or sigmatropic rearrangement reactions. Sigmatropic shift or rearrangement reactions. What is the sigmatropic shift or rearrangement reactions here? In Greek, tropic means change or movement or migration. Movement or migration. Right? So, change, movement or migration of sigma bond, or movement or change of sigma bond, migration of sigma bond, shift or rearrangement, right? Shifting or rearrangement takes place. Migration of sigma bond from one position to another position within the molecule, similar to the electrocyclic reactions, right? Only one molecule is participated. Sigmatropic reactions also it may be takes place unimolecular within the molecule, right? So these are the reactions of unimolecular. Sigmatropic reactions are the reactions of the unimolecular reactions, right? So one position to the another position within the molecule through the cyclic transition state. It may be takes place. All the pericyclic reactions are going to be cyclic transition state. So migration of sigma bond, movement or migration of sigma bond from one position to another position within the molecule with cyclic transition state. Migration of sigma bond means sigma bond attached groups are there. Migration of sigma bond means sigma bond attached group or atom is there. That migrating group or atom from one position to another position. One position means suppose this is the old position, one position to the new another position is new positions. One position to another position, old position to new position within the molecule with cyclic transition state. Only one molecule is enough for the sigmatropic rearrangement reactions or sigmatropic shift. Unimolecular reactions. These are the reactions of unimolecular, like the electrocyclic reactions. Unimolecule. That unimolecule is conjugated system, it may be there. Conjugation, it may be conjugated pi bond molecule, it may be there. See, listen. So here it is in the conjugated pi molecule. This exit may be any group or atom. Migrating sigma bond. This is the migrating sigma bond. How you can identifying the migrating sigma bond? The sigma bond is migrating sigma bond. How you can identifying the migrating sigma bond? Right? So you take the conjugated molecule, the molecule in the unsaturated. So you take the alpha position nearer to the unsaturation. This alpha position is always saturated alpha position. You can select as the saturated alpha position. Saturated means sp3 carbon. Saturated alpha position which is adjacent to the unsaturation. Selected as saturated position. Saturation position, that is the alpha position adjacent to the unsaturation. This is the saturated position adjacent to the unsaturation. That is the alpha position. Select alpha position or saturated position that is adjacent to the unsaturation. Here saturated carbon, that is adjacent to the unsaturation. Right? First identifying the saturated position adjacent to the unsaturation. That saturated position attached sigma bond you can select it as migrating sigma bond. This sigma bond, this saturated position attached sigma bond is migrating sigma bond. Migrating sigma bond. Migrating sigma bond migrates from one position to new position. That means old position to new position. Right? Or that means migrating sigma bond means that attached group or atom. Attached group or atom. So first identifying the saturated position. So this is which one? sp3 carbon position, that is alpha position. The sigma bond is which sigma bond? Migrating sigma bond. Migrating sigma bond. This is which one? Migrating group or atom. Migrating sigma bond. So after identifying the migrating sigma bond, give the numbering for the each end of the migrating sigma bond 1 1. Each end of the or each termini of the migrating sigma bond, you can give the numbering is 1 1 1 1 1 and 1 both sides, and continuing the till the end of the unsaturation. Here there is no unsaturation, here it is there, further it may be not there, so only group X it may be selected atom or group, so that's why I can give the 1 numbering. If it is further continuation is there, you can also given the numbering is 1 2 3 like that. So this is 1 2 3 till the end of the unsaturated migrating sigma bond. Both the terminals you can assign the numbering is 1 1, both sides of the migrating sigma bond. Right? So the sigma bond is going to be migrating, takes place from one position to another position. One position means this is the old position. Where attached sigma bond is 1 1. This 1 is the old position, that is considered as origin, migrating origin. And from which position? One position to new position. That new position must be the termini position. That another position, new position is must be the termini of pi bond. This is the termini of the conjugation. This is the termini. Migrating termini position. Terminal position. On which position? 2, 3. There are 2 choices it may be there. So it is going to be migrating of the sigma bond from one position. That means the origin position to the new position, that is terminal position. Through the which one? Cyclic transition state. Through the cyclic transition state. This is the migrating termini, migrating origin, migrating sigma bond, migrating group or atom. Right? How can you select the migrating sigma bond? That is the saturated position, adjacent or nearer to the unsaturation. That is the migrating sigma bond. Right? So this alpha position is always must be saturated position. Right? So through the cyclic transition state, it is going to be takes place through the cyclic transition state. It is happening through the cyclic transition state. What will be happening? Here it is. Through the cyclic transition state, migration of the sigma bond takes place. Migration of the sigma bond takes place through the origin position to the terminal position. One position, that is the old position, that is which one? Origin. That is origin. Origin to the termini position of the pi bond. Origin to the termini. So it is going to be takes place, this migrating group or atom. That means migrating sigma bond. So what will be happen here in this case? Double bond C. It is going to be X. Right? So before that numbering is which one? 1, 2, 3. This is 1. So the migrating sigma bond migrates from one position to the 3 position. One position to the, before that here, one position to the 3rd position. One position to the 3rd position. Right? This shift is called as sigmatropic shift. Sigma bond, if it is migrating, takes place. Sigma bond is going to be migrating, takes place. Sigma bond is going to be migrating, takes place. See, listen. Suppose if it is another one more, if it is there. So here in this case, not only the one termini, for a selected molecule, more number of terminal atoms also possible, more termini positions also possible. So what will be happen if it is more termini positions are there, right? So migrating sigma bond, so you can select first This is the unsaturation, this is unsaturation, but here it is not saturated, not saturated, here it is only the saturated position is there. This is the alpha position or saturated position adjacent to the unsaturation. You can select it, it is an origin, that is sp3 carbon, saturated position. So this alpha position attached group it may be there, that sigma bond you can select it, that is a migrating sigma bond. Migrating sigma bond. This group is which one? Migrating group or atom. So here it is migrating group or atom migrates from origin to the terminal position. Origin to the terminal position. So after identifying the sigma bond, so you can give the numbering is 1 1 for the both the ends of the migrating sigma bond. So continuing till the end of the pi system or unsaturation. Till the end of the unsaturation. 1, 2, 3, 4, 5. Both ends also. If it is there, here it is also, you can give the numbering. Otherwise, simply leave it for 1. So here it is, there are two termini positions are there. Here it is termini 1. Here it is also termini 2. Two terminal positions are there. So the migrating sigma bond migrates from origin to the terminal position. So if it is takes place from this position to this position, or if it is takes place from this position to this position, there are two choices will be there, migrating terminals. If it is termini 1 position, if it is migrating takes place, what will be happen? Termini 1 position migrating takes place, right? So termini 1 position, if it is going to be migrating takes place, this position, 1 1 position to 1 3 position. 3 position attached takes place, C double bond, C 4 5. This is the termini position, right? So this position to the here, old position to the new position. New position is the termini 1, that is third number. So if it is takes place here from going to be takes place, and this is happening. So this my sigma bond is migrating takes place means this is cleavage of the sigma bond takes place. Breakage or cleavage of the sigma bond takes place. Right? So it is going to be breakaging takes place, right? It is shifting takes place from this position to this position. Right? So here it is double bond. Or this can be shown like this. So here it is also. This bond going to be electrons. So rearrangement takes place, that means shifting takes place here, and this is going to be here. Right? If it is termini 2 position, if it is going to be takes place, termini 2 position, terminal 2 position, right? Second terminal, termini 2, termini 2. So if it is takes place from this position to this position, if it is breakage takes place, here it is bond formation takes place, then it is going to be turns to this. Right? So what will happen here? This position is breakage takes place, bond. So it is going to be form the CX, then it is shifting the electrons like this, rearrangement takes place. X. So here it is 1, 2, 3, 4, 5. Right, termini 2 position. First position to the 5th position. Here it is first position to the 3rd position. It is takes place. Or else this can be shown like these symbols also. So this is going to be happen. Right, like this also. So any one format, but here it is, if it is going to be this termini, this double bond is shifted to this. If it is going to be this termini, this double bond is shifted to this is going to be shifted to this. Right, within the molecule. So that's why it is, which the double bonds are in conjugation, it is going to be interchanging takes place, rearrangement takes place. Right, termini 1, termini 2. Right, so the termini positions are here, C3 carbon, and another one is C5. One is C3, another one is C5. So based on that, most number of the termini positions, not in always, but most of the molecules, in most of the molecules, terminal positions are odd number of positions. Odd number of positions. Odd number of positions. That means 1, 3, 5. Sorry, one is like this here. So 3, 5, 7, 9 like this. Most of the case terminal positions are odd number of positions. If the molecule is like this, suppose so here you can select this one or this one is the unsaturation. With respect to the unsaturated, here saturated position is there, here it is saturation position is there. So you can identify any one of them, no problem. So you can select this is the alpha position or this is alpha position. This is the saturated position adjacent to the unsaturation. Saturated position adjacent to the unsaturation. This is also like this. So the saturated position adjacent to the unsaturation, the attached sigma bond is migrating sigma bond. Migrating sigma bond. This is migrating sigma bond. Then give the numbering after identifying the migrating sigma bond. Give the numbering for both ends of the migrating sigma bond 1, 1, and continuing the numbering till the end of the unsaturation. Till the end of the unsaturation. Here there are two possibilities are there. Suppose this is migrating origin. This is terminal. Here it is group, suppose. So the migrating sigma bond migrates from this origin position, first position to the third position is one choice. Only one end will be changed. Another one end is same group if it is there. Or else the migrating sigma bond changes from 1, 1 position to the 3, 3 positions. 1, 1 position to the 3, 3 position. That means from this position to this position. There are two types of changes also it may be possible through the cyclic transition state. Through the cyclic transition state. So if it is breakage of the bond takes place and shifting from 1, 1 position to the 3, 3 positions also it may takes place. Or 1, 1 position to the 1, 2, 3 position. Right? Or 1, 1 position to the 3, 3 position. 3, 3 position takes place, both the terminals of both the migrating sigma bond, both the attached positions are new positions. That shift is later it may be considered as IJ shift. So based on this terminal, there are two possibilities here. I can explain the two possibilities. So if this position, this group, shifting of this migrating group from one position to the third position. So what will happen? One position to third position, that it is going to be takes place. Right? So like this, or if it is breaking takes place, if it is going to be happening. Right? So whatever that it is going to be takes place, C double bond C. So before that 1, 2, 3, these group positions are what will happen? 1, 2, 3. This is the migrating group. So this is the old position. This is the new position. Only one end will be changed. Only one end will be the new position. Another one end is the old position. If both ends will be new position, both ends will be new position. If both ends will be new position, that means from this one to the here, through the cyclic transition state, through the cyclic transition state. If this position, so what will happen? Like this. So this position, from this position to this position, right? This position migrating sigma bond going to be takes from 1, 1 position to the 3, 3 position. 1, 2, 3, 1, 2, 3. This one will be happen from this position breakage takes place. Here this position formation takes place. From the rearrangement of the pi bond, pi electrons takes place from this position to the here to here, right? So if it is both the ends will be different, migrating sigma bond from 1, 1 position to the 3, 3 position, both the ends will be different. When it is going to be 1 position to the third position, so 1 to third, So this is 1 to 1 3 shift. The migrating sigma bond from 1 1 position to the which one? 3 3 position. Here it is. This is considered as 3 3 shift. 3 3 shift. Right. So which one it may be there? 1 is like this position and 3 is the this position. And here 3 is the here this position. Here 3 is here. Both I and J, both terminals are different. Both ends are different. Here only one end is different. That is 1 to third position. Only one end it may be different. One is going to be third. Right. So further, this is going to be shifting that Ij shift and 1J shift it may be there. Further it is classified Ij shift and 1J shift. And further, if it is sigmatropic shift or rearrangement takes place, sigmatropic shift or rearrangement takes place, the number of pi bonds changing or sigma bonds changing is not there. That means number of pi bonds and sigma bonds are same, remains same. After the sigmatropic shift also it may be same. Suppose if it is going to be taken, the sigma bond is there, again sigma bond is happening, again sigma bond is happening. One pi bond is there, that is shifted to here, but here it is same, pi bond is there, number of pi bonds are 1, pi bonds are not changed and sigma bonds are also not changed, remains same when it is going to be sigmatropic shift takes place. Sigmatropic shift takes place. Further, the sigmatropic shift is classified into the based on the terminal positions and origin. Based on the origins, that means migrating sigma bond attached positions, migrating sigma bond attached positions. Based on the shifting, sigma bond is shifting from which position to which position. Further, it is classified as 1J sigmatropic shift, Ij sigmatropic shift. 1J and Ij sigmatropic shift. Right? This is the important one. Concept is. Without concept, you cannot apply that. Right? Then order or designations. How can you show the sigmatropic shift? The order or designations of the sigmatropic shift. Sigmatropic shift. Order or designations. How can you represent that? The order or designation for sigmatropic shift, one is 1, J order, and another one is Ij order. 1J order, Ij order. 1J, Ij. 1J, Ij order. 1J order means migrating sigma bond migrates only after migration. Migrating sigma bond attaches to migrating sigma bond attaches to. If it is 1J shift is going to be takes place, migrating sigma bond changes. Migrating sigma bond changes only one end. Only one end. That means after migration of the sigma bond, you can consider the both ends. Only one position is the new position. Only one end. That means after migration of the sigma bond, only that means migrating sigma bond attaches only one new position. Only one new position. If you can take the both ends, only one is the new position, another one is the old position. Suppose X is the group. So this is the migrating sigma bond. Based on the migrating sigma bond, how can you select the migrating sigma bond? The saturated position near to the unsaturation. This you can take the migrating group origin. So if it is here, it is also unsaturation is there. This is also origin. There is a two origins also possible, depending upon that. So migrating sigma bond migrated sigma bond, this attached, suppose this is a group, suppose you have to consider the group, right? So you can give the numbering for the both ends of the migrated sigma bond. After identifying the migrated sigma bond, both ends will be given 1 numbering and continuing till the end of the unsaturation of the both sides, right? Both sides. So if it is 1, 1, 2, 3, if it is there, this is the origin and terminal position. This migrating sigma bond migrates from origin to terminal. Suppose if it is going to be takes place from this one to this one, 1, 2, 3, 1, 3 sigmatropic shift. Through the cyclic transition state, it may be takes place. 1, 3 sigmatropic shift. So first position, this migrating sigma bond, first position to the third position, right? Like this, or like this, whatever it may be, right? So through the transition state. Like this. So here it is 1, 2, 3. This earlier numbering is 1, 2, 3, and here it is 1. So migrating sigma bond, before positions are 1, 1. After that, 1, 3 sigmatropic shift, 1, 3. This is the old position. After the migration also, this is old position, and here it is the new position. New position from 1, 1 position to the 1, 3 position. 1, 3 position. So here it is, sigma bond changes only one end. So not changes this position is 1. This is the new position. One end. That means only one is the new position. One side is the new position. That shift is the 1, 3 shift. Here 1 J shift. 1 comma J shift. J is 3 here. 1 J shift. Suppose here it is. This is the termini 1. Here it is the termini 2. With respect to this unsaturation, this is the saturated position. Here it is migrating sigma bond. This is sigma bond. So give the numbering 1, 1 for each end till the end of the unsaturation. So here suppose before that is 1, 1. If it is 1, 3 shift takes place, that means from this one to this position, breakage of the sigma, cleavage of this sigma bond, migrated sigma bond takes place, and it is going to be here and here. Right? So what will be happen here it is, or this position is shifted to here and this is going to be here, whatever it may be for your convenient point of view. Right? So rearrangement of the electron, pi electrons takes place from this position to this position. If it is new bond formation takes place, this is going to be shifted to here, right? X 1, 2, 3, 1, 4, 5. So after the migration, 1, 3 sigmatropic shift takes place. Only one end will be the new position 3. From 1 to 3 position, it is going to be takes place. Both in this earlier end is, so here it is 1 and 1 position to the which one 1 and 3 position. So this is 1, 3 sigmatropic shift. Suppose 1, 7 sigmatropic shift, 1, 7, that is going to be takes place from this position to this position. Sorry, 1, 5 from this one takes place. Right? What will be happen? Here it is H is there. H is there. I have not mentioned C means H. H is there. Right? Because 4 bands you have to satisfy this H. H is you write that H. I have not mentioned H means just I can show the examples. Right? I can write one type of format case. But here it is you can add H. Right? From this position to here 1, 2, 3, 4, 5. Right? So from first position to the 5th position. So this is after, that means after migration of the sigma bond, both end, this end will be 1 and another one end will be 5. So this shift will be 1 5 shift. 1 5 shift. Suppose here what will be happening? So this is the adjacent position, saturated position to the unsaturation, or adjacent saturated position to the unsaturation. This is also adjacent saturated position to unsaturation. The sigma bond is the migrating sigma bond. So give the numbering for the both sides 1 1 and continuing till the end of the unsaturation. Numbering will be given. Suppose here 1 3 shift takes place. 1 3 shift takes place. This is going to be here through the cyclic transition state. So this position to the here. This bond is migrating, breakage takes place and is going to be here, here, or it is going to be here and here, whatever it may be, right? So it is takes place, right? Like this, you can show, suppose, right? Or this is breaking takes place from this one to this one, whatever it may be. So before, after that, the positions, you can identifying the positions. This is the first position is attached to the 3, right? This is the 1 2 3. This is going to be here. Starts with the migrating sigma bond from here. 1 2 3. So this is the sigma bond. From this, what we can identifying that? So one is the world position in the earlier one. This shift is the earlier example. I just write here. If it is given like this, so this is the migrating sigma bond. With respect to the unsaturation, alpha position of the sigma bond will be considered as the migrating sigma bond. So further, this is hydrogen, 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 hydrogen. It may be there. I cannot mention that. So just I can explain generalized point of view. The examples particularly given that CH2, CH, CH2, that will be given later. It is any substance also it may be given. So here it is, numbering will be given with respect for each ends of the migrating sigma bond. Starts with 1 1 and continuing till the end of the unsaturation. If the shift is suppose 1J shift, only J point if it is changed, that means here it is migrating sigma bond positions, here it is 1 is the old positions. After migrating, 1 is the old position, J is the new position. That means here it is suppose the shift is, it may be the 1 3 shift, 1 3 shift from this one to this one. 1 3 shift, what will be happen? 1 3 shift, 1 3 shift it maybe takes place. This bond it is going to be here. That means here it is pi electron rearrangement takes place through the cyclic transition state. Through the cyclic transition state. This is going to be here, or this double one electron shifted here, and this is going to be here, right? So whatever that through the cyclic transition state, these arrows are not indicating the generation of the charge, not shifting of the bonds. It is not there. So just through an idea point of view, I mentioned that. Right. So here it is 1 2 3. This 1 2 3, 1 2 3 carbons. So this is going to be here. That's why double one is there. So 1 2 3. Right. So this is the migrating sigma bond. The sigma bond is migrating from 1 1 position to 1 3 position. 1 3 position. 1 is the new position. When ij shift is 1j shift is takes place, j is the new position. Right. So here it is 1 3 shift takes place. 1 3 shift takes place. Suppose this is going to be same one. ij shift takes place. I mentioned that another one shift is ij shift. When ij shift meets the migrating sigma bond. Migrating sigma bond. Here it is the old positions are there before. Before that it is old positions. Migrating sigma bond. So if it is ij shift, it maybe takes place. Both ends will be the new positions. The migration sigma bond. Migrate after migration takes place. Both ends will be the both ends with respect to the migrating sigma bond new positions. That means ij. Both are new positions. New positions. Suppose if ij shift takes place. So here it is 3 shift, that new positions, not 1 1. So that means odd number of positions are the terminal positions, not these two. So you may consider this 3. Suppose 3 is the terminal position. So both ends will be changed. That means migrating sigma bond from 1 position to the 3 position. 1 position to 3 position takes place from breakage of this migrating sigma bond, and here it is formation takes place through the cyclic transition state. Through the cyclic transition state, it may be going to be takes place. So what will happen? So like this cyclic transition state, right? Pi electron derangement takes place, and between the CC 1, 2, 3 and 3 carbons, bond formation takes place. Sigma bond formation takes place, and this is going to be shifted here. This is going to be shifted here, like this. After migrating the sigma bond, both ends will be the new positions 3 and 3. Right? This shift is which is called as IJ shift or IJ order. IJ shift or IJ order, that is 3 shift. Both ends of the migrated sigma bond, both origins will be having the different positions, so that is new positions. Right? New positions. Suppose R is any group, if it is 1-3 shift takes place, how can you explain that 1-3 shift? So with respect to the unsaturation, this is the alpha position, saturated position. The sigma bond is the migrating sigma bond. So both ends of the migrating sigma bond, you give the numbering is 1, 1. R is any group, I am not mentioned the particular group. If it is that particular group, suppose like this, extended conjugation is there, you may given the numbering also 1, 1, 1, 2, 3 like that up to that end of the unsaturation. But I generally mention that R 2, 3. So 1, 2, 3. That means this position is going to this group or shifting takes place from 1 to 3. How to like this? Through the cyclic transition state, I am not mentioned that bond. Shifting it is not accurately. So right here is 1, 2, 3 position. What will happen? This from 1 to 3 position. 1, 2, 3. Right? So what will happen here? It is 1, 2, 3. It is going to be takes place through the cyclic transition state. It is happening 1, 2, 3. Sorry, 1, 2, 3. Right? So this is going to be shifted here. Right? So here it is 3 position. It may be takes place. So this is the migrating sigma bond. So before that, it is old position is 1. Another one old position is 3. But here it is 3 is the new position. Before that 1, 1 is the old positions with respect to the migrated sigma bond. After that 1, 3 is the position. So that's why this is which shift? 1, J shift. 1, J shift. Through the migrating sigma bond that it may be happening. Migrating sigma bond. Next one, suppose another one more example. Same one, if it is given like this, you don't confuse. The molecular arrangement may be given like this or this. Both are same. What will be happen? 1, 2, 3. This is the unsaturated position, saturated position near to the unsaturation or adjacent to the unsaturation. Right? So give the numbering is 1, 1. This is the migrating sigma bond. Right? From 1 position to 3rd position. 1 position to 3rd position. Through the which one? Cyclic transition state. Through cyclic transition state it is takes place. So here it is. This is the migrating sigma bond. Both ends will be the 1 and 3. Before that 1 and 1. So that means here it is 1 and 3. It may be there. 1 is the old position. 3 is the new position. That group attached group. So that's why the shift is 1, 3 shift. Migrating sigma bond from 1, 1 to 1, 3. 1, 3 shift. And another one it may be considered as 1, J shift. 1, J shift. Through this cyclic transition state, it is going to be takes place. The cyclic transition state. Right? if it is happening, suppose. This is the molecule. In this molecule, with respect to the unsaturation, this is the saturated position, sp3 position is there. There is alpha position. That alpha position attached sigma bond is considered as migrating sigma bond. This is saturated position adjacent to the unsaturation. Right? So both ends will give the 1-1 numbering for the migrating sigma bond and continuing till the end of the unsaturation. Till the end of the unsaturation. Here it is unsaturation is ending takes place. Right? So if it is, there are two terminis are there. Here termini 1 is there. Here it is termini 2 is there. Termini 2, 3 and 5 it may be there. Suppose here it is the migrating group or atom, it is going to be takes place from 1 to 3. 1-3 position, 1-3 shift takes place, what will be happening? If it is going to be takes place, 1-5 shift takes place, what will be happening? Right? If it is going to be takes place 1-2-3 shift, that means this is going to be here 1-2-3. So this double bond is not changed. The double bond position is not changed. That means the pi electrons are not involved. Only here it is 1 pi bond, 1 sigma bond. That means sigma 2 and pi 2. So that is 4 pi electrons. 1-3 means 1 plus 3. That is going to be 4. 4 pi system. This is happening. Further it may be happening. This is 4 pi system. 1-3. So what will be happening? This is not changed. So what will be happening? This position is which group? R. 3 position, the sigma bond migrating takes place from 1-1 position to 1-3 position. 1-3 position. Further that, this is going to be here. Pi electrons is going to be shifted to here, or this one is going to be here. So between 1 and 2, what will happen? Due to the pi electron arrangements, double bond formation takes place. This is which shift? 1-3 shift. 1-3 shift. The migrating sigma bond migrates from 1-1 position to 1-3 position. Third position. R group is going to be attached to the third position. 1-5 shift means R group is going to be attached to the fifth position. When R group is going to be attached to the fifth position, what will be happening here? It is pi electrons arrangement takes place. This double bond and this double bond is also involved. That means sigma 2 pi 4. That means having 6 electrons. 6 electrons means which one that is having? 4n plus 2 pi system. Or 1, 5 means 1 plus 5 is going to be 6. 4n plus 2 pi system. Further the shift is with shift like that. So here it is R. R is the old position. This is attached to the fifth position. Right? This double bond is here. 3-4 position double bond. And 1-2 positions double bond. Double bond is exchanging takes place, these positions. But the number of double bonds changes 0. Number of sigma bonds changes 0 in the sigmatropic shift. That means the sigmatropic shift takes place, the double bonds, that means the reactant and as well as the product, the number of pi bonds and sigma bonds will be same. It is not going to be changed. Right? So what will be happening like this? So this migrating sigma bond is 1-5 is the new positions. Before that, 1-1 it may be there. This is 1, J shift. 1-5 shift. Right? Suppose another one more example. Another one more example you can take. D is the deuterium. One 3 shift takes place, what will be happening? 1-5 shift takes place, what will be happening? Here it is. This is the, with respect to the unsaturation, this is the saturated position. Saturated position attached sigma bond is migrating sigma bond. Both ends will give the numbering is 1-1 and continuing till the end of the unsaturation. So here it is, 3 is the odd position, termini is there, 5th is the odd position, termini is there. There are 2 terminis are there. The migrating sigma bond migrates from 1 to 3 position. That means here it is deuterium is going to be attached to this 3 position. This group is going to be attached to the 5th position. What will be happen? 1-3 shift if it takes place. If 1-3 shift takes place, what will be happening? Like this. Right? So 1-1 position here it is breakage takes place and 3 position here it is sigma bond formation takes place. This is going to be shifted here. Right? So this double bond is not changed. So 3 position is going to be D and this 1-2 position double bond is there. So when it is going to be attached to this is shifting. When it is going to be attached to this is shifting. Both are shifting. When 1,5 shift takes place, this is going to be here. What will be happen? Like this. Right? 3, 4 positions, 1 double bond is there, and 1, 2 positions, 1 double bond is there. Right? So that means here it is this one is also involves. That means 2 pi bonds, that means 4 pi electrons involves, and sigma 2 electrons. 1,5 shift it maybe takes place. So, but here it is 1,3 case, this is not changed. Right? 1, 2, 5, 5th position. 1, 1 position breakage takes place, 1, 5 position is formation takes place, sigma bond. Right? So, when it is these electrons are going to be 1, 2 position, and this is going to be 3, 4 position. Right? Or if it is formation takes place, shifted here. Right? So, this is going to be which shift? 1,5 shift. 1,5 shift. When 1,5 shift takes place, like this. Right? So, next one example. Next, another one more example of the sigmatropic shifts. Next, another one more example. Another one more example of the system. Suppose sigmatropic shift. If it takes place, this is the saturated position. This is the saturated position, or this is the saturated position. You can select any one. Suppose this is the saturated position with respect to this unsaturation. This is the migrating sigma bond. Both ends will give the 1, 1 numbering, continuing till the end of unsaturation. Right? But here there is no unsaturation. I can end this position. If it is unsaturation is there, I can give the unsaturation also. But here it is, there is no unsaturation further. So only 1 it may be there. Right? So 1, 1 it may be numbering, it may be takes place. Suppose 1, 3 shift it may be takes place. 1, 3 sigmatropic shift. That means this bond it may be breaking takes place, and it is going to form here. And this is going to be shifted here, or like this. Right? So what will happen here? It is between 1 and 2 positions, double bond is there. 1 and 2 positions, double bond is there. And 3 and 1 position. This is the 1 position. 3 and 1 position. Here it is like this. This I can write here. Right? So I just write this molecule is going to be better to write here. So 1, 3 shift takes place. 1, 2, 3. This migrating sigma 1 from 1, 1 to 1, 3 positions. 1, 3 position, 1, 3 shift takes place. Right? Next one, if it is going to be takes place, another one more example is so here, suppose with respect to the double bond, this is the unsaturation, this is the saturation, this is the saturation. So suppose you can select this is the saturated position, 1, 2, 3, right? And migrating sigma bond, right? This is the migrating sigma bond. Attached group it may be having given the 1 position. 1, 1 is the numbering. So this is the migrating sigma bond with respect to this double bond. Right? So saturated position near to the unsaturation, alpha position you can select, and this is migrating group, and both ends will be given 1, 1 numbering until the end of the unsaturation. This 1, 1 position bond breakage takes place. If it is 1, 3 shift takes place, because only 1 terminal is there, that is the odd terminal here in this case, 3 position. So this 1, 1 position it may be breaking takes place. So what will happen? 1, 3 position bond formation takes place. 1, 3 position bond formation takes place. That means like this. Right? So what will happen? So this position it is 1, 2 position is bond formation takes place. This 1, 1 position is bond it is going to be breaking takes place. So 1, 3 positions here it is new bond formation, sigma bond formation takes place. 1, 1 position sigma bond is breakages, 1, 3 position is formation takes place, right? So this is the migrating group. So migrating sigma bond from 1,1 position to the 1,3 position. If it is 1,3 shift takes place, this will be happen. 1,3 shift takes place, right? So it is sigma bond migrating takes place from 1,1 position to 1,3 position, right? Suppose another one more example of the, this is allyl vinyl ethers. This is allyl group. This is vinyl group. Allyl vinyl ether. In allyl vinyl ether, if it is oxygen is there, instead of carbon, oxygen is there. So you can take the, this is with respect to the unsaturation, this is the saturated position, this is the migrating sigma bond, and both ends will give the numbering is 1,1 and continuing till the end of the unsaturation. Continuing till the end of the unsaturation. Alright. So if it is 1,3 shift takes place, what will happen? 1,3 shift, these shifts are considered as Claisen rearrangements. Claisen rearrangements. Further, it may be there in the pericyclic reactions case also. It may be takes place in the thermal conditions, photochemical conditions. Later I can explain. This is takes place under which conditions, and what is stereochemistry also later I can explain. Just if it is Claisen rearrangement takes place, if it is 1,3 shift takes place, what will be happening? 1,3 shift. That means here it is 1, 2, 3. 1, 2, 3. What will be happen? This is happening. Right? This 1, 2 positions, the pi bond is there, the pi electrons arrangement takes place, and 3 group which is attached to the first group. Right? 1, 2, 3. So the migrating sigma bond from 1,1 position to the 1,3 positions. This is 1,3 shift takes place. 1,3 shift takes place. This is not going to be changed. So only 4 electrons, this 2 pi electrons and this sigma 2 electrons. If it is the same molecule, is going to be 1,5 shift takes place. 3,3 shift. There is no 5th position, 3,3 shift. If it is going to be 3,3 shift takes place, this migrating sigma bond from 1,1 position to the 3,3 position through the cyclic transition state. 3,3 position means this is going to be happening, and this here it is formation takes place, right? Or here this is happening, right? So what will be happening here? It is the resulting product are like this: 3,3 positions, new sigma bond formation takes place, and here one, 2 positions double bond, and here it is 1, 2 position double bond. 1, 1 position it will migrate sigma bond breakage takes place and form 3, 3 positions. Both ends will be new position. This is which shift also called as IJ shift. IJ shift. Right? So this is also Claisen rearrangement. 3, 3 shift it maybe takes place, and 1, 3 shift takes place in allyl vinyl ethers. That is having which one shift? Which one? Claisen rearrangement. That is proposed by the Claisen further. And another one more example. If it is R, this R. So what will be happening? What will be happening? So the examples, in this type of examples, here it is not possible, because here it is, with respect to this double bond, this is the unsaturation, but here it is, this is the not the sigma bond, saturated sigma bond is not there, because this is attached to the double bond. So that's why I can modify it like this. Okay. right? With respect to this unsaturation, this is the saturated position, or with respect to this unsaturation, this is the saturated position. Give the numbering is 1, 1 for the both ends. That means this is the migrating sigma bond, right? 1, 2, 3, and you can also start here. It is 1, 2, 3, 4, 5, like this. If it is takes place 1, 3 shift, 1, 3 shift, what will be happen? If it is takes place 1, 3 shift, migrating sigma bond from 1, 1 position to the 1, 3 position, this position, from these two positions to this position. So what will be happen? Migrating sigma bond migrates from 1 to 3 position, 1 to 3 position. So what will be happen here? It is double bond O, right here, or this is happening, right? Migrating sigma bond from 1, 1 position to the 1, 3 position, 1, 3 position, 1, 3 position, it is takes place. So there is no change in the 2, 3 position double bond, right? So after that, if it is supposed tautomerization takes place, O minus, then it is going to be attached to this H plus. So this is tautomerization takes place. Tautomerization takes place. So what will be happen here? It is when it is going to be tautomerization takes place, OH, O minus, this is going to be attached to this position, oxygen. So H plus, it may be combined with the oxygen, O minus, OH, right? R. Right. So when it is 1, 3 shift takes place like this, if it is 1, 5 shift takes place, what will be happening? Or 3, 3 shift takes place. Before 1, 5, 3, 3 shift takes place. 3, 3 shift. 3, 3 shift takes place, what will be happening? The allyl vinyl ethers type linkage. So here is going to be here. This bond electrons are shifted to this, and it is going to be attached to this, and like that, right? Through the cyclic transition state, you can write, right? So these two are not changed because 3 position, up to the 3 position only it may be there. So similar like this, double bond O, right? And it is going to be attached to the third position. Third position, it may be there. R group is there. R group is there. This is the third position. 3, 3 shift, because it is going to be attached to this. Further, 2 and first position, 1 and 2 positions, double bond is there. This is happening. 3, 3 shift, this is. See, migrating sigma bond from 1, 1 position to the 3, 3 position. 3, 3 position. If it is tautomerization takes place, what will be happen? Here it is. Again, OH. Sometimes it may be given, tautomerization is not given. Which one is the product? Directly this product will be given, right? So you may imagine this hydrogen position is going to be shifted here, and this this electrons are shifted to here, making the double bond, and O minus and H plus is combined with the O, right? OH, right? Sometimes it is not given. Directly this product OH is given. You don't confuse that. Tautomerization takes place. This will be formation takes place after that. Right? Because automatically this converted to the most stable compound. Right? So if it is 1, 5 shift takes place, what will happen for the same molecule? For the same molecule is going to be 1, 5 shift takes place. So that means it is going to be this position, 1, 5 shift. 1, 5 shift. So 1 to 5th position, this position. So same thing like this, right? And it is here, it is here, right? So what will happen? 3, 4 positions, double bond is there. Here this position, 1, 2, 3, 4, 5th position, it is attached to the first group, 5th position. Right? 1,5 sigmatropic shift takes place, this will be happening. 1,5 sigmatropic shift takes place. Suppose 5,3 sigmatropic shift or 3,5 sigmatropic shift, 3,5 sigmatropic shift takes place, what will happen? This is going to be here. This is going to be here. Right? So 3,5 sigmatropic shift, if this takes place, what will be happening? Three 5 sigmatropic shift. This is going to be here in this position. Similar one. Right? Here, 5th position is going to be attached to the 3rd position. This is the 3rd position. Right? 5th and 3rd. R group here it is. 1 and 2 positions, double bond may be there. Right? This will be happening. This is the resulting product. If it is with shift, 3,5 shift takes place from 1,1 to 3,5 positions. 3,5 shift takes place. Right? So this is the examples of the given molecules. If it is further extension also, it maybe takes place. The double bond. So many shifts also it may be possible. Right? With next one example. All these are the examples to better to understand the sigmatropic shift. Next, another one more example of this similar kind. I can write here O. Suppose if it is double bond is there here in this position, like 2-3 shifts it may be possible, but I mentioned that 1, 3, 3, 5 odd number of shifts, so that's why I can select here. Right? So the double bond positions. So this is with respect to this saturated position, with respect to this considered as a saturated position. So it may be given 1-1 numbering for the migrating sigma bond. First identification of the migrating sigma bond. Right? Later it may be given the 1-1 numbering. How to identify the migrating sigma bond? With respect to the unsaturation, right? So the alpha position to the unsaturation, that is adjacent position to the unsaturation, that is the saturated position. You select as the saturated position most of the cases. Right? That is the alpha position. So if it is the alpha position, you give the numbering for the both ends. Right? 1-1. Alpha position sigma bond you can select. Right? For this it may be double bond is there or not, it may be not a criteria. Right? So you can select this one. Right? So here 1, 2, 3, 4, 5 till the end of the unsaturation. 6, 7 is also given, but I am not interested. So it may be up to the 3 to 5 it may be given. So it may be given most if it is going to be takes place 1 to 7 shifts also it may be possible, 3 7 shifts, 5 7 shifts, like that. For 6 7 also it may be given. Right? So if it is 1-3 shift takes place, what will be happening? 1-3 shift. So like this. Like the earlier one, 1-3 shift takes place. These two positions are not changed. Only here, here C double 1 O, and it is going to be 1, 2, 3. It is going to be attached to the first position. Right? So here, 1-3 shift. If it is tautomerization takes place, this double bond, here it is O minus, hydrogen is going to be attached to this H plus, OH. Tautomerization takes place, what will be happen? This will be happen, tautomerization takes place, OH and double bond is there. Right? Keto-enol tautomerization takes place. Right? If it is 3-3 shifts takes place, suppose 3-3 shifts. 3-3 shift means like this. This is not changed. These two are not changed. Right? So what will happen? 3-3 shift takes place. Right? So here it is double bond O. Right? It is going to be attached to the third position. It is going to be attached to the third position. It is going to be attached to the third position means here it is third position, suppose 3-3 shift takes place. So 1-2 positions double bond is there. 1, 2 positions double bond is there. Here it is breakage of the bond. Migrated sigma bond from 1, 1 position to the 1, 3 position, right? So from 3, 3 position from this. So this is not changed, right? 4 and 5th, right? So here it is 1, 3, the sigma bonds 2 electrons and another pi electrons, 2 pi electrons. So that is total 4 electrons are there. This system is also further classified into the 4n pi electron system. 1, 3 system is 4n pi. 3, 3 is 6 electrons. That is having 4n plus 2 pi electron system. You can easily say that. So or from this which one? 2 sigma electrons and here it is 2 pi and here it is 2 pi. Right? So that's why here it is totally 6 pi electrons. Suppose for here 3 phi sigmatropic shift, 3 phi sigmatropic shift. This is 3 and this is the 5th position, 3 phi sigmatropic shift. 3 phi sigmatropic shift. Like this. So what will be happen? 3 phi sigmatropic shift takes place. This bond is not changed. This is 6, 7 bond, right? Pi bond. It is not going to be changed. Here 3 phi, right? 1, 2, 3, 4, 5. 5th and 3 position, sigma bond formation takes place. Right? Migrate sigma bond from 1, 1 position to the 3, 5 positions. So 3, 3 shift, 1, 3 shift, 3, 5 shift. You don't confuse. Not write this 3, 5 shift here. So 1, 3 shift like this, 3, 5 shift like this, 3, 3 shift like this. Right? 3 is going to be 5. If 5, 5 shift is also takes place like this. Right? So 3, 3 shift takes place. So this 1, 2 positions, similar group position. 1, 3, 1, 2 positions, which one it may be there? Sigma pi bond, it is going to shift to the 1, 2 positions. And for here it is, which one it may be there? Or same thing it may be there. Right? 4 and 5th position. Better to practice, right? With the practice only, you can perfect this type of examples, right? So many shifts also possible. I cannot write here. You can write also 1, 5 shift. You can also write 5, 3 shift also for this position. It's going to be here 5, 3 shift or 5, 5 shift. This is going to be here 7, so 7. So another one term is also there here. 6, 7, 1, 7 shift is also possible. 3, 7 shift is also possible. Different types of shifts you can write based on that examples, right? So another one molecule, another one example. CH3. 1, 3 sigmatropic shift takes place. What will be happen? Or if it is resulting product will be given. The product also given, sometimes examination point of view, product will be given. Which shift takes place? That is called as which shift? That is called as which shift? Right? Or if the product is given like this, that is which shift? Right? So here it is, this is the unsaturation. With respect to the unsaturation, saturated positions are these two, and these two is the saturated positions. So this attached groups is migrating sigma bond, suppose you can take, but here it is not there. You can take, here it is not there. You can take, further it may be, so here it is migrating sigma bond from this position, here it is, suppose these two positions it may be, you can take it as saturated positions. Suppose this is formation or not, you can check them. See, listen. With respect to the unsaturation, these two are the saturated positions, right? So you can take the saturated position CH2 and another one hydrogen CH3. So that's why here it is there. So with respect to the unsaturation, this is the saturated position, alpha position, right? sp3 position, attached sigma bond, you can select it as the migrating sigma bond. Migrating sigma bond. Then you can give the numbering is 1, 2, 3. right? With respect to this unsaturation, saturated positions are these two or these two. If you can select these two, what will be happen? If you can select these two, what will be happen? If it is select this one, is this possible or not? You can check them. So 1,3 shift it may be takes place. That means here it is 1,1 position to the 1,3 shift. 1,3 shift. So if it is hydrogen, 1,1 position to the 1,3 position. 1,1 position to the 1,3 position, and 1 and 2 positions with what will be happen? Pi bond formation takes place. The shift is which shift? 1,3 shift. 1 position to the 3rd position. 1,3 shift. If it is, suppose here, this is the same example. Here it is also saturated positions are there, alpha positions. If this is taken as a sigma bond, this is not formation takes place. So here it is alpha position attached groups are there. Saturated position is also hydrogen is there. So this is the migrating sigma bond. Both ends will be given the 1,1 numbering till the end of the unsaturation. 1,1, 2, 3. So the migrating sigma bond migrates from which position? 1,1 to the 1,3 position. Suppose what will be happen? This is possible or not? You can check them. 1, 2 positions double bond is there, and 3rd position hydrogen atom is there. So 1,3 shift. So it is 1,3 shift takes place. This one will be formation takes place. Right. Next, suppose another one more example. Or S plus O minus like this. Here 2,3 shift takes place. What will be happen? With respect to this unsaturation, this is the saturated position, right? This is the migrating sigma bond. Give the numbering for both ends 1,1, right? And till the end of the unsaturation, 1 and 2, because S plus O minus is the double bond O type. Plus and minus is going to be double bond O, right? The double bond. So that's why 1 and 2 it may be given. 2,3 shift takes place. This 1,1 position to the 2,3 positions, it may be sigma bond formation takes place. What will be happening, right? Here S plus is going to be neutralized, and here this one will be takes place. This negative charge is indicating also 2 electrons, right? So it may be 1, 2, 1, 2, 3. So this 2, 3 positions, new sigma bond. Before 1, 1 position, after that 2, 3 positions, it may be sigma bond formation takes place. 2, 3 position sigma bond may be there. This is which shift? 2, 3 shift. This is possible in specific type of examples of this. Or P plus double bond O here. 1, 2, 3 and 1, 2 numbering is given. This is the migrating sigma bond with respect to the unsaturated saturated position. That saturated position attached to sigma bond is the migrating sigma bond. If it is 2, 3 sigmatropic shift takes place, what will be happen? Right? So it is going to be here O minus, and these electrons are there like this. So what will be happen? P O and like this. So 1, 2, 3, 1, 2, 2, 3 sigmatropic shift. 2, 3 sigmatropic shift. This is an example of the 2, 3 sigmatropic. So these kind of examples which are there, right? Or else another one more example I can take. If it is 1, 3 shift takes place, what will be happen? 1, 5 shift takes place, what will be happen? Another one more example. Number of examples are there. For the point of the stereochemistry discussion, I can again explain. Another different examples also we can take in the stereochemistry point of view. So this is general definition and how and examples, generalized examples. Without stereochemistry, what will be happening? It is which type of shifts takes place. And I have not mentioned thermal position or photochemical position which is allowed, right? That is also not mentioned. But the shift, here it is 1,3 shift, 4 pi electrons which are there. 1,5 shift, 6 pi electrons, 6 electrons, 6 pi electrons or 6 electrons. That is going to be 4n plus 2 pi system, right? Here it is another one more. Deuterium. With respect to this unsaturation, this is the saturated position. With respect to the saturated positions, right? Based on the resulting products, you may decide whether it is saturated position or this is the saturated position. Here, saturated position attached groups are there. So, if this shift takes place, what will be happen, right? So, this is the saturated position, right? Both ends will be given 1,1 numbering, or you can give the numbering is 1,1, or you can give the numbering is 1,1. And continuing till the end of the unsaturation. These two are in conjugation, so that's why I can give the numbering is till the end of the unsaturation. Not going to be here, only unsaturation point of view. Ending for the unsaturation. Suppose if it is 1,3 shift takes place, what will be happening? 1,5 shift takes place, what will be happening? Resulting product or what? 1,3 shift means 4n pi system. This is 1,5 means 4n plus 2. 4n plus 2, 1 plus 5 is going to be 6. You may imagine like this. So what will be happen here it is, 1,3 shift takes place. So this 1,1 position to 1,3 position, right? So finally this product, this is not changed because 4,5 is not involved. Only up to that third position. Third position it is what will be happening, deuterium is attached to this third position. This 1,1 position is breakaging takes place, and 1,1 position is breakaging takes place. What will happen? 3,1 positions bond formation takes place. Right here, deuterium. These two are like these groups, not this one. Right. This is the resulting product. Which shift takes place? 1,3 shift. 1,5 shift takes place. What will happen? Again like this. 1,5 shift takes place, the product is like this. So 5th position is what will be happen? Deuterium is there, right? 1 and 5 positions, 1 position to the 1 and 5th position. So here it is 4 and 3 positions, double bond is there, and 1, 2 positions, double bond is there, and deuterium is there, right? This is which shift? 1,5 shift if it is takes place. 1,5 shift it is takes place. This is sigmatropic shifts and certain examples of the sigmatropic shifts. What will be happening in the sigmatropic shifts, right? So identifying the sigma bond. So how to identifying the migrating sigma bond? You can take the saturated unsaturated position that is adjacent to the unsaturation, right? So after the migrating sigma bond identifying, both ends will be given 1,1 numbering till the end of the unsaturation. Right? Then it is going to be migrating sigma bond takes place from 1,1 position to the 1,3 positions or 1,5 positions or 1,7 position or 3,5 positions, 3,3 positions. What will happen depending upon the resulting product, that shift it may be takes place. Right? Next one. Another one is the chelotropic reactions. This less number of examples are there and also less importance in the pericyclic reactions, chelotropic reactions. In chelotropic reactions, formation of two new sigma bonds takes place. Formation of two new sigma bonds formation takes place for a single atom or a group. Single atom or a group. For a single atom or a group, formation of two new sigma bonds takes place simultaneously. Right? For carbene and olefin, right? Carbene and olefin, right? So here it is formation of two new sigma bonds takes place simultaneously. Formation of two new sigma bonds takes place simultaneously. through the cyclic transition state, formation of new sigma bonds takes place simultaneously. This is one sigma bond, sorry. Formation of two new sigma bonds takes place simultaneously. Here sigma bond and here it is sigma bond. Sigma bonds formation takes place simultaneously. This is an example of the cheletropic reaction. If it is, this is also reversible reaction. If it is ring opening takes place, again it may be regenerated. Right? Cheletropic reactions. Cheletropic reactions. Another one, if it is takes place, another one more example of the cheletropic reactions are, if it is cis-1,3 butadiene and SO2, here it is also through the cyclic transition state, it maybe takes place. This is also reversible reaction. So what will be happening here? Double bond O, double bond O. Two new sigma bonds formation takes place simultaneously for a single atom or a group that it is having cheletropic reaction, right? So if it is reopening takes place, again it will be regenerated, right? Again it will be regenerated. Through the cyclic transition state, it may be takes place, right? And another one which is having group transfer reactions. So further their stereochemistry will be discussion takes place, and either it is photochemical allowed or thermal allowed, right? Whether it is 4n pi system, 4n pi to pi system, later I can explain the cheletropic reactions, stereochemistry, and under which conditions that is allowed, right? Again after that explaining the continuations point of view later. Just general definition. Group transfer reactions. Group transfer reactions. Group transfer reactions is particularly ene reaction is an example for this group type of group transfer reactions. In the group transfer reactions, what will happen? Migration of atom or group. Migration of atom or group from one position to another, one molecule to another molecule, from one molecule to another molecule. From one molecule to the another molecule, migration of atom or group takes place, or within the molecule from one position to another position it maybe takes place, or within the molecule from one position to another position it takes place, that is having group transfer reaction. Group transfer reaction. So particularly the ene reaction is the best one. In ene reaction, what will happen here? It is, suppose if it is 1, 2, 3. So this is ene, right? And enophile in ene reaction. Transfer of hydrogen from this molecule to the here, that means ene to enophile. Transfer of hydrogen from ene to enophile. Transfer of allylic hydrogen to ene, double bond. Allylic hydrogen to double bond, that is ene reaction, or from ene hydrogen. Ene, that means allylic position hydrogen to the enophile, olefin, right? So this reaction which is considered as the ene reaction. In ene reaction, ene is the allylic system and olefin is the enophile. Transfer of allylic hydrogen to the olefin. Transfer of allylic hydrogen to the olefin. So transfer of allylic hydrogen to the olefin, this position, allylic hydrogen takes place, right? Here 1, 2, 3. Here it is sigma bond formation takes place between those two, and transfer of allylic hydrogen from which position? Allylic position to the olefin position, right? This shift is called, this one is called as group transfer reaction. Or transfer of hydrogen from diimide to the olefin, diimide to the olefin, transfer of hydrogens from diimide to the olefin, right? So this reaction is called as here N triple bond N, and this hydrogen, and here hydrogen is transfer takes place. Transfer of the hydrogen from which one position to this diimide to the olefin. So these two hydrogen will be taken and this hydrogen will be taken, and here it is N triple bond and CH2, CH2, HH. CH2, CH2, HH. That is having which one? Diimide to the olefin. This is also an example of the group transfer reaction. Group transfer reactions. Right? Or further one more example of the group transfer reaction. Group transfer reaction, if it is hydrogen, suppose hydrogen is there, or if it is there, suppose. So transfer of the hydrogen from this one to this. So what will be happening here, it is here double bond formation takes place and transfer of hydrogen from this molecule to here, double bond positions. Here or H, R. So hydrogens from this molecule to here is also a group transfer reaction examples. Right? So there is no specific importance of the group transfer and chelotropic reactions for this point of view. While stereochemistry will be discussion takes place, and which conditions it is allowed based on theories I can explain later. Right?